We are talking about similar triangles, and we want to identify similar triangles using the AA similarity postulate and the SSS and SAS similarity theorems. We also want to use similar triangles to solve problems. Okay, so there's 3 shortcuts to prove 2 triangles are similar. The first one is angle-angle or AA similarity. Now, really it should be AAA, but if you know 2 of the angles, you can always calculate the third one. So if 2 of them are congruent, then the third one is also going to have to be congruent. It says prove 2 pairs of corresponding angles are congruent. Okay, so to start with, I'm going to just mark on these triangles, and you can't just mark your own congruent marks. In the example problems, they will be marked for you already. Okay, so we have angle A is congruent to angle D, and angle C is congruent to angle F. So these 2 angles are congruent, and these 2 angles are congruent. So now we have angle, 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 angle. So if angle A is congruent to angle D and angle C is congruent to angle F, then triangle ABC is similar to triangle DEF by angle-angle similarity postulate. So that's angle-angle similarity. The next one we have is side, side, side. And this one is a little bit more difficult to illustrate and a little bit more difficult to prove. So you have to prove the lengths of all corresponding sides are in proportion. So basically, we are going to set up a proportion or extended proportion. So, and you can actually use the names when given to help set up your proportion, because corresponding sides should be labeled correctly. So if we look at this first one, we have A and C. So we can put AC in the numerator. And then we also have first and last are going to be PR. Then we have the first 2, which are AB. And the first 2 for this one, which are PQ. And then we have the last 2, which is BC. And the last 2 are. And then notice that we have the corresponding side stacked vertically. And we have the, so PR is going to be the smaller triangle, are all on the bottom. So this is small. So these are the small triangles. And this is the large triangle. So we kept the proportions the same way that we have in our previous lessons. So now we can substitute in values. We're still going to have that extended proportion set up. And what we're checking for is to see if all these proportional sides are congruent or equal. Not congruent, equal. So we have AC right here. So AC is 13. And that should be correspondent to PR, which is 6.5. Another way that you can tell is 13 is the largest side and 6.5 is the largest side. So in order for this proportion to work, the biggest values have to go together. So 11 is the next smallest, which is going to be BC. So 11 goes here. And that is a side. And that was the middle side. So that's going to be over 5.5. And I forgot to mark. That's a side. And that's a side. And then our smallest side left, AB goes in the numerator. And PQ goes in the denominator. And then all we have to do now is check to make sure that all these ratios are equivalent. So 13 divided by 6.5 is 2. 10 divided by 5 is 2. And 11 divided by 5.5 is 2. And so all of these proportions are equal. So then triangle ABC is similar to triangle PQR by side similarity. And we proved it mathematically below.